two swimmers leave point A on one bank of the river to reach point B lying right across on the other bank. One of them crosses the river along the straight line AB, while the other swim at right angles to the stream and then walks the distance that he has been carried away by the stream to get to the point B. What was the velocity u of his walking if both swimmers reached the destination simultaneously? The stream velocity v naught is equal to 2 kilometers per hour, and the velocity v dash of each swimmer with respect to water equals 2.5 kilometer per hour. So let us examine this figure here. This is our stream, and let the width of the stream, let us say that this distance is s. This is the width of the stream, s. Now swimmer 1, it swims in along this path, along the red path, but we are given that the swimmer velocity with respect to water is v dash. So for swimmer 1, if v1 is the resultant velocity, what it means is, because the stream is flowing towards the right, I am assuming that the stream is flowing towards the right, the swimmer 1 should actually travel in this direction, that is, he should try to swim in this direction, in the v dash direction. If the swimmer 1 tries to swim in v dash direction, then the resultant velocity v1 can be along the path AB. So what it means is, what is the magnitude of v1? From Pythagoras theorem we know that magnitude of v1 is simply v dash square minus v naught square. So this is the magnitude of v1. So what is the time that the swimmer 1 takes in crossing the river? The time that swimmer 1 takes is the distance s divided by the resultant velocity v1, which is v dash square minus v naught square. Now let us consider the case of swimmer 2. In swimmer 2, it is said that he is actually swimming at right angles to the stream velocity. So actually he is making no attempt to swim in the straight direction on the path AB. He is actually swimming at right angles, so he is trying to swim straight. And now, because the stream has a velocity towards the right, his resultant velocity will be v2. However, to solve this problem, what is the vertical component of the velocity, which is v dash, and what is the vertical distance, s? So the time taken in crossing the river, let's say t1, the time taken by swimmer 2 in crossing the river is simply s by the vertical component of the velocity, which is v dash. In the same time t1, what is the distance? Let us say this point is called C. For example, let us say that this point is C. What is the distance BC in the same time? We know the horizontal velocity is v naught. So distance BC is equal to v naught times t1, which is v naught s by v dash. Now we are also given his walking velocity, which is u, which is what we are supposed to find. So suppose the boy can walk with the velocity of u, what is the time that he will take in covering the distance BC? Let us call that time as t2. So what we know is, if this is the distance, the time taken in crossing this distance is this distance divided by velocity u. So u will come in the denominator. So what is the total time taken by swimmer 2? Total time taken by swimmer 2 is t1 plus t2. Total time taken by swimmer 2 is t1, which is s by v dash, plus v naught by v dash s by u. Now we are told in the problem that the boys reach the point B simultaneously. So what it means is that total time taken by swimmer 1 and total time taken by swimmer 2 are actually equal. So we just equate these two equations. That is, this is equation 1 and this is equation 2, and we simply equate this equation. What we get is s will cancel out from the numerator. So what we are left with is 1 divided by square root of v dash square minus v naught square is equal to 1 by v dash plus v naught by v dash times 1 by u. And now we simply solve for u from this equation. So for solving u, what we can write is that v naught by v dash times 1 by u is actually equal to v dash square minus v naught square minus 1 by v dash. Now this is equal to, if you take the LCM, this is equal to v dash minus v dash square minus v naught square divided by v dash times v dash square minus v naught square. Now for solving u, we just cross multiply. What we get is u is equal to v naught so u is equal to v naught times v dash times square root of v dash square minus v naught square divided by v dash times v dash minus square root of v dash square minus v naught square. This v dash cancels, and what we are left with is v naught times square root of v dash square minus V naught square divided by V dash minus square root of V dash square minus V naught square. And this is our answer. We can simply put the values and get the answer. So let me go to another page to make space. So I'll write the expression for u again. What we found out was that u is equal to v naught times square root of v dash square minus v naught square divided by v dash square minus v dash square minus v naught square. So v naught is equal to 2 kilometers per hour and v dash is equal to 2.5, so this becomes 6.25 minus v naught is 2, so this becomes 4. This is 6.25. Sorry, so this is not there. It is v dash minus, I have made a mistake here. Yes, it is v dash, not v dash square. So let us correct this mistake. This is simply v dash. So this is 2.5 minus 6.25 minus 4 is 2.25. So this is equal to 2 times 2.25 square root is 1.5 divided by 2.5 minus 1.5, and therefore we get 2 times 1.5 is 3 and 2.5 minus 1.5 is 1. So our answer is 3 kilometers per hour. So the boy can walk at the speed of 3 kilometers per hour.